Hello everyone, welcome back to my YouTube channel, and in today's video we are going to learn part 2 of practice set 8.2. We have already finished part 1 of this exercise in our previous video, wherein we were asked to find out the various values of sine, cos and tan and complete the given table. So we have done that by using various formulae and substituting them in the questions given. Now in today's video, we are going to learn about the second part of this exercise where we are going to make use of the table which I have already taught you in the previous video. The table of these values. Let us see what am I talking about. Now, the second question that is given in this exercise is find the values of. Whereas the first question was complete the following table, which is done in the previous video. So now, to solve this question, find the values of, there are 6 questions given to us and we have to find out the answers for it. Okay, so for doing that, it is necessary for us to know this table, which we have learned how to find out the values of these equation of these various trigonometric ratios according to the various ideas that we had shown in the previous video. So what we're going to do is to solve these kind of questions, it is very necessary for you to learn these values or remember the trick to solve the get these values. Okay, so because in the when you'll solve the actual questions, please note that this table will not be given to you. Okay, we have to remember the values or we should know the trick to solve this equation, to solve these questions. Okay, now let us proceed. So we have to find the values of such questions like 5 sine 30 and 3 tan 45. So 5 is okay. 5 has been multiplied with sine 30 and 3 has been multiplied with tan 45. So we need to know the values of sine 30 and tan 45. So for that, we either need to learn the table or we need to solve it and find out the value. So as of now, I am showing you the table only for the explanation purpose, but while in examination or while solving these questions, you do not get these tables. Okay, so you have to remember this table. Now 5 is sine 30 plus 3 tan 45. So what will come in the first equation? 5 will write as it is, and sine 30. So let us check what is sine 30 in this table. So if I look here, sine 30, this is sine and this is 30. Okay, so sine 30 is what? 1 upon 2. Okay, and 3 into tan 45. So this is tan and this is 45, right? So tan 45 is 1. So I've written that here. Okay, now if once we get this, we are supposed to solve it further. So 5 into half. 5 into 1 is going to be 5 upon 2 and 3 into 1 will be 3. So 5 upon 2 plus 3. 5 into 1 is 5 upon 2 into 3. Now if you look here, one is the fraction and another one is a natural number. So how do you add these numbers? You can't add 5 plus 3 which will give you 8. No, because if you look at this, it has these are when it's a fraction, one is a natural number, so in such case you directly do not add it, but rather you solve it in a different way. Now I will convert this natural number into a fraction, so this becomes 3 upon 1. Yes, now look at the denominator. Now 2 and 1. You can add two fractions only when the denominators are same. Now in this case the denominator is 2 and the other denominator is 1. So I have to see to it that the denominator of both the fractions are same. When both the denominators will be same, I will be able to add the numerators. So now if here is 1 and 2, so I want such number. I mean, first thing is I want to change both these numbers into such a number which will be same. Okay, so I have to change 2 and I have to change 1 also, and I have to change it to the same numbers. So what I'll do is I'll try to find out a number which comes in both the tables, the table of 2 and in table of 1. But in that whatever number will be common to both the numbers, that number we are going to take. For example, let me write down the table of 2. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8. Okay, so I'll write this much only. Now ones table I'll write 1 ones are 1, 1 twos are 2, 1 threes are 3, 1 fours are 4. Do you find any number which is common to both? Now if you look here, you will say you find 2 common and 4 common, right? But whenever you have more than one numbers common, you always there is one rule that which says that it is the least common multiple, means you have to take the first number which is common to both. Like in this case, the first number which is common to both is 2. Okay, so what we are going to do is we are going to change this number into 2. We are going to change 2 also to 2, and we are going to change 1 also to 2. So if I want to change this 2 to 2, I will have to, this 2 is will be remaining the same, so 2 will be remaining same, so I'll have to multiply this by 1. So 2 into 1, and I have to change this 1 to 2. So if I want to change this 1 to 2, I'll have to multiply this with 2. Okay, so when I'll multiply 2 with 1, I'll get 2. I'll multiply 1 with 2, I'll get 2. Similarly, what we do is whatever operation we do in the denominator, we have to do the similar thing in the numerator. So this becomes 5 into 1, and this becomes 3 into 2. Okay, so likewise, we have to write down that in the next step. So 5 into 1 and 3 into 2, and in the denominator 2 into 1 and 1 into 2. Okay, so I hope this is clear to you. Now, you simply have to multiply and add the numbers. Now, if you look here, 5 into 1 will be what? 5 into 1 is going to be 5, and 2 into 1 is going to be 2. Similarly, so 5 into 1 will be 5, 2 into 1 will be 2, plus 3 into 2. So 3 into 2 will be 6, and 1 into 2 will be 2. So this thing we'll write down in the next one. So 5 upon 2 plus 6 upon 2. Okay. Now, since the denominator is same, the denominator is 2, we add the numerator. So 5 plus 6, and common denominator will be 2. So 5 plus 6 will be 11 upon 2. So this is our answer for the first question. Now let us solve the second question. 4 upon 5 tan square is 60 plus 3 sine square is 60. So I need to know the values of tan 60 and sine 60. So I'll have to refer this table. Now let us try solving this example. So I'll write down 4 upon 5. Now what is this? Just look, 4 upon 5 is written as it is. Tan. Now look here, tan square 60. So first let me find out what is tan 60. So look here, tan 60 is root 3. So I've written root 3, but since there is a square here, I have to put the square also to it. Okay, so this becomes tan square. So tan square, because of tan square, it becomes root 3 square. Now next I write down plus as it is, the plus 3 as it is, sine 60. So sine 60 is root 3 upon 2, and since there is a square, we put this square. Okay, now we are going to solve this. Once we put the values, we just have to solve it nicely. Okay, so I write down 4 upon 5 as it is, and root 3 square. So children, root 3, see, whenever you get the square of any square root, like for example root 3 square will be always 3, or if you have root 7 square, it will be only 7. Okay, so similarly here root 3 square will be 3. So this will remain 4 upon 5 into this root 3 will be 3. Root 3 square will be 3 plus 3 into root 3 square will again be 3, but this 2 also has square on this. Okay, so 2 square will be 4. Okay, so this is what you're going to get in our answer. 4 upon 5 into 3 plus 3 into 3 upon 4. Okay, so let us write it down. So this is what we get when we solve by taking the square. Okay, now let us solve this. Now 4 threes is going to be 12, children, and 3 threes is going to be 9. If you multiply this, see, 4 threes are 3 threes are. Okay, so 4 threes will be 12, 3 threes will be 9, and the denominators will be 5 and 4. Now again, if you look here, we have two different numbers. We have two different denominators. Like for example, you have 5 in the first one and 4 in the second one. So I need to change these numbers again to the common denominator. So let me solve this by writing the table of 5 and 4. So 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25. Okay, I'll write down this and let me check for 4 also. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, and 4 fives are 20. So do you get any number which is common to both? Yes, this number 20 is common to both. So what am I going to do is I'm going to change 5 also to 20 and 4 also to 20. So if I want to change 5 to 20, I'll have to multiply this by 4. Yes, similarly, I'll have to multiply numerator also by 4 because I've multiplied denominator. Now, if I want to change 4 to 20, I'll have to multiply because this is the 4 5s are 20 it is, right? So 4 5s are 20. So this will also become 9 5s are. So in this way, we'll get 12 into 4, 9 into 5, 5 into 4 and 4 into 5. So 12 fours is 48, 9 5s is 45 and the denominators will be same 20. So we'll add this 48 plus 45 upon 20 which will give us 93 upon 20. So this is your answer for the second question. Now let us move towards the third question. 2 sine 30 plus cos 0 plus 3 sine 90. So let us find out the values first from the table. Now let us write down. So now I'll write down 2. See how I've written this 2 sine 30. So let us check what is sine 30. See, sine 30 is here, which is half. So for sine 30 I've written half. Cos 0. Cos 0 is 1. So I've written cos 0 is 1 and 3. This 3 is here and sine 90. So let us check what is sine 90, which is 1. So for sine 90 we have written 1. Okay. Now after doing this we have to after writing this much we have to just do it by solving. Now if you look here, first one is this 2 into 1 by 2. If you look here, this 2 and 2 will get cancelled and you'll get only 1. This one will remain as it is and 3 ones will become 3. So in the next step, since 2 gets cancelled, what remains is 1. This another 1 and 3 ones is 3. So that gives me answer as 5. That's it. Now the next one. Fourth question. Tan 60 upon sine 60 plus cos 60. So first let me find out the values using the table. So tan 60 will be root 3. If you look here, tan 60 is root 3. Sine 60 is root 3 upon 2 and cos 60 is 1 upon 2. So that's what we have substituted here. Now, so we have this as numerator. This is numerator and this is the denominator. This entire thing is the denominator, right? So we'll first write down numerator as it is and let us try to solve the denominator. So since the denominator has two fractions in it, children, you have 2 as a common denominator, so you can directly add the numerator of the denominator. So root 3 plus 1 I write as it is because we cannot add an irrational number and a natural number, right? So root 3 plus 1 will remain as it is. We cannot add them upon 2. Okay, now how do I solve this? So what will I do is I'll write down this in some different manner. Rather than writing it as numerator upon denominator, I will write down this is numerator, this is denominator full. Okay, so instead of writing like this, what I'll do is I'll write down it in the form, instead of fraction, I'll write down it in the form of numerator divided by denominator. So what will I get? So if I write down in this form, I'll get root 3 divided by root 3 plus 1 upon 2. So root 3 divided by root 3 plus 1 upon 2. Now I want to solve this. Whenever we solve this, children, we change this sign to multiplication. Yes, and when you change the sign to multiplication, the next fraction becomes a inverted, or you take the reciprocal of the next fraction. So what will happen? This 2 will go up and root 3 upon plus 1 will come down. So when we do that, we get root 3 as it is. This changed to multiplication, and if you look, 2 goes up and root 3 upon root 3 plus 1 comes down. Now in this case you cannot cancel anything. You cannot cancel root 3 and root 3 because if root 3 could have been alone here in the denominator, you could have cancelled it, but it is having plus 1 with it, so you cannot cancel root 3 and root 3 in this case. So what we do is, when you cannot cancel anything, you multiply numerator with numerator, which will give you 2 root 3, and you'll write down the denominator root 3 plus 1. So this is your answer. Now fifth question. Cos square 45 plus cosine square 30. So first let us refer the table. So cos square 45. So cos 45 is 1 upon root 2, the whole square. Since there is a square, we have to take the square. And sine square 30. So sine 30 is half. So since there is a square, we write down square. Now 1 square will be 1, root 2 square will be 2, 1 square, and the other fraction 1 square will be 1 and 2 square will be 4. So now if you look here, since we are not having the denominator same, we are going to change it. So if I want to change 2 and 4, 4 is the number which comes in both the tables. So 2 2s are 4, and hence I multiply numerator also with the uh, 2, denominator also with the 2, and in the next fraction I multiply both with 1. So in this way I get a common denominator 4 and numerators will be 2 and 1. So when your numerators are the denominators are same, you can add the numerators, which give me 3 upon 4. So this is your answer for the fifth question. Now let us move to the sixth one. Cos 60 into cos 30 plus sin 60 into sin 30. So let us first have a look at the uh, values. Now I have taken these values. If you look from the table, I need to know the table for this. So how am I going to get the table? See here. So what I have done is cos 60. For cos 60 is 1 upon 2. So for cos 60 I have written 1 upon 2, and for cos 30 I have written root 3 upon 2. See, cos 30 is root 3 upon 2. Similarly, for sin 60 is here root 3 upon 2, and sin 30 is 1 upon 2. Yes. So likewise, I've substituted all the four values from the table, and then I have to look at the denominators. Now here is a multiplication. When you are multiplying two fractions, no children, when you are multiplying, you don't have to look at the denominators to be same. When you add or subtract, that time the denominators shall be same. So since you are multiplying here, you shall not check the denominators whether they are same or not. Okay, so when you are multiplying, just simply multiply numerator with numerator and denominator with denominator. So root 3 into 1 will give you root 3, and 2 2s will give you 4. Plus, next is root 3 into 1 will give you root 3, and 2 2s will give you 4. Now in the next step you have plus. Here you should check the denominator whether it is same or not. So here, since we are having the same denominators, we don't have to worry about it. We can directly add the numerators. So root 3 plus root 3. So root 3 plus root 3 will be 2 into root 3, 2 into root 3, because there are 2 times root 3, and upon 4 as it is. Since there is multiplication here, children, we can cancel 2 ones are and 2 twos are 4. Yes. So this will give me root 3 into 1, which will be root 3, and denominator from will change from 4 to 2. So our answer will be root 3 upon 2. Now the next. Now this is a different kind of question. This kind of question we have already done in the part 1 exercise. If sine theta is 4 upon 5, find cos theta. So if you have sine and you have to find the cos, we know a very common formula that we use is sine square plus sine square theta plus cos square theta is equal to 1. And then we substitute, we get the answer. So since sine theta is 4 upon 5, sine square theta will be 4 upon 5 the whole square plus cos square theta is equal to 1. So the square of 4 is going to be, okay, so what I do is I take both, I keep cos square alone since I have to find the cos square. We keep it alone and we take this on the other side. Okay, so plus 4 upon 5 square becomes minus 4 upon 5 square. So cos square theta is 1 minus 4 square is 16, children. This 4 square is 16, and upon 5 square will be 25. Okay, so in this way we get this much. But now since we have to solve this further, I will have to solve this in such a way that I get a normal fraction. So how do I solve this? I will be cross multiplying here. So 1 into 25 will give me 25. 16 into, there's nothing here means there is 16. So 25, 1 into 25 is 25. And 16 into 1 is 16. So 25 minus 16 and the denominator will remain the same. So 25 minus 16 will be 9 and 25 will write as it is. But I'm not supposed to find out cos square, right? We have been told to find out cos theta. So we'll have to shift this square here. So when the shift square will go on the other side, it will change to square root. So cos theta will be square root of 9 and square root of 45, which will give the square root of 9 is 3 and square root of 25 is 5. Let us have a look at the last question. Of course, for theta is 15 upon 17, then find sine theta. So again, this we are going to use the same formula. Since cos is given and sine we are supposed to find out. So sine square theta plus cos square theta is equal to 1. So let us substitute. Sine square is not given, so it will remain as it is. Cos theta is given to us 15 upon 17. So we'll write on the square of 15 upon 17 is equal to 1. So sine square theta I'll keep alone and I'll take this on the other side. So this will become 1 minus 15 upon 17 square. So sine square theta is 1 minus 15 square is 225, 17 square is 289. Now again I'm going to cross multiply. 1 and 289 will be 289 and 225 into 1 will be 225 and the denominator will remain the same. Now in the next step I'll subtract this. So 9 minus 5 will give you 4. 8 minus 2 will give you 6. So answer will be 64 upon 289. But this is cos square theta. We are supposed to find out the cos theta. I'm so sorry. This is sine theta. Okay, this is sine theta. So since we are supposed to find out the sine theta, this is sine. So this is sine square theta. Okay. So the sine square theta. So this also will change to, in the next step also, this will become sine square theta. Okay, so this will be sine square theta will be 64 upon 289. So the sine theta will be square root of 64 upon square root of 289. So finally we'll get sine theta as 8 upon 17. This will be sine theta. Okay, so sine theta will be 8 upon 17. So this is our final answer. Thank you.